All right, we are going to do a quick little lesson on valence electrons, what they are, how to determine how many are in an atom, and then how to draw Lewis dot diagrams to represent the number of valence electrons in an atom. So just remember, in a neutral atom, the number of negatively charged electrons has to always equal the amount of positively charged protons, because the negative and the positive have to cancel out in order to be neutral. So we're going to go a little bit deeper into our electrons and talk about the difference between a kernel electron and a valence electron. So in a kernel electron, these are all the inner electrons, and we'll talk about some examples down here. So these are all the electrons except for our valence electrons. The valence electrons are only the electrons that are in the outermost energy level. So this number of valence electrons is always between 1 and 8. If an atom's valence electron is full, so it has 8 electrons, then it's a noble gas. And those noble gases are going to be found in the last group on the right, which is group 18 on the periodic table. So let's look at some examples so we can start to tell the difference between these two types of electrons. So let's actually start with the valence electron. So in sulfur, we have the first energy level, the second energy level, the third energy level. And remember, as you go from the first out to in this case, the third, you're moving away from the nucleus. So we're looking at the last energy level. So this 6 is my number of valence electrons. That last number is always going to be number of valence electrons. The kernel electrons are just everything else. So I have 2 plus 8, so this would give me 10. Okay, we usually don't concern ourselves with these kernel electrons. It's really those valence electrons that we're going to focus on. So we're just adding them up. Strontium, here's its configuration, and these configurations come right off of my periodic table. Okay, so for strontium, if I let that focus for a second, okay, I have 2, 8, 18, 8, 2. So that's what you would normally look at when you're doing questions about your valence electrons. So let me just fix that for a second. Okay, so we look at the outermost shell. So this is my first shell, second, third, fourth. In my fifth shell, the outermost shell, I just have 2 electrons. So that means I have 2 valence electrons. I have 10. 10, 28, and 6, I think, is 36. All right, and then with gallium, same thing. Outermost shell or principal energy level has 3. So I have 3 valence electrons for gallium. So I have, in this case, if I add up the first 3 shells, I get 28. Okay, so you have to be able to not just define valence electrons, but determine how many valence electrons you have. So one way that we represent these, and this will become really important when we get to our some stuff with periodic table and bonding, is how to draw electron dot diagrams. So these only illustrate the valence electrons, which means you should never have more than 8 dots. If you have more than 8, you're doing something wrong. So the 2 parts are represented by the symbol, which is the kernel, all the inner electrons, and the nucleus. And then the dots are just representing those valence electrons. Sometimes you'll see X's used, and that's acceptable too. So we're going to be writing the symbol. We're going to look at the electron configuration number, determine the number of valence electrons using the last number in the configuration, and then we're going to use dots to represent them. And you're going to see me put them in specific spots. Really, as long as they're all there, you're okay, but strive for kind of doing the order that I'm going to do it in. So if you go on to the next page, it says to draw the Lewis dot diagrams for the following main group elements. We're going to skip over our transition metals. So if we look at the first set of elements, okay, the first column, this is group 1. So we have hydrogen, which has just 1 electron, so it only has its 1 valence electrons. You'll see lithium is 1, sodium's last shell is 1, potassium's last shell is 1. So you should see that in group 1, all of these elements just have 1 valence electron. So we're just going to start, I usually start on the right-hand side. So these guys all just have one valence electron. Okay, if we look at group 2, okay, here we have group 2, beryllium, magnesium, calcium. These guys, they have different amounts of electrons, but their valence electrons are the same. So group 2 for beryllium is 2 valence electrons, magnesium is 2, calcium is 2. So all of group 2 have 2 valence electrons. And the first 2 I always put together. So these are my first. Group 2, they're 2 valence electrons. So you will start to see a pattern here. If we look at group 13, so I'm going to hold that up for you. For group 13, boron has 3 electrons, aluminum is 3 valence electrons, gallium is 3 valence electrons. So you see that all 3 of these have 3 valence electrons. They're all in group 13. So when we look at 13, think of the 3 there, okay? And you can find it in their electron configuration too. So I'm going to start with the first 2 together and then my third one up top. So I have 1, 2, 3, 1, 2, 3. All right, we're going to keep going here. All right, for our next one, carbon, silicon, germanium. Okay, you'll see 4, 4, and 4. So in group 14, they all have 4 valence electrons. Group 15 is all 5. Group 16 is all 6. 17 all have 7 valence electrons, and then 18 has 8 valence electrons. Remember, that's the maximum amount of valence electrons it can have. So kind of just working off of that. I'm not going to fill in this whole chart for you for the video. You can go through your notes and do this on your own. But in group 14, you're going to have 4 valence electrons. So you're going to see with carbon, I'm going to fill in 1, 2, 3, 4. So I start separating them around kind of like a clock. In 15, I have 5 valence electrons for all of these. So for nitrogen, I'm going to have my first 2 together. So that's 1, 2, 3, 4, 5. 5 valence electrons. Group 16, so like oxygen, has 6 valence electrons. So I'm going to have 1, 2, 3, 4, 5, 6. So group 17 has 7 valence electrons. So fluorine's 2, and 3, 4, 5, 6, 7. Okay, and that pattern would continue down each of those groups. And then group 18, we do have to be careful, I should say, because helium, I'll pull that up again, only has 2 electrons. So that only has 2. The rest of the group is going to have their 8. So helium is just 2, so be careful, like a little star next to that one. But then you're going to see neon is 1, 2, 3, 4, 5, 6, 7, 8. We'll fill that right up. If you wanted to keep the same pattern that I was doing across, like with argon, you would have your 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the periodic table, which we'll get into a little bit later, we'll kind of go back to this, but right now you just have to be able to draw Lewis dot diagrams by identifying the number of valence electrons, okay, and then drawing the dots correctly around the symbol. And last thing, as you saw, elements in the same column of the periodic table have the same number of valence electrons, which we're going to see as we move forward that gives them similar chemical properties between elements in the same group. All right, that's it.